Section 6 involves compound inequalities. So we've been working with inequalities this entire chapter. Now we have this new word, compound inequalities. Compound inequalities just means that there's more than one inequality in the same problem. So you could actually write that down right there, like more than one inequality in the same problem. That's all that means. And the way that we're going to have more than one inequality in a problem is by using these words, and, or. And or are used in math very similarly to the way that they're used in English. So we're going to learn how they're used in English first, and then we'll kind of relate that to how it's used in math. So in the English language, and or have a very important difference. And means both parts of a sentence need to be true for the whole thing to be true. If one part is false, then the whole sentence is false. If both parts are false, the whole sentence is obviously still false. But both are true, then the sentence is true. So, your teacher's first name is Mike. Is that true? Maybe some of you don't know, but it is. That's true. And he is from Michigan. Is that true? Yes, I am originally from Michigan. So, my first name is Mike, and my original state is Michigan. Is this statement true? Yes. I was born in Michigan. An octopus has 8 legs. Is that true? Yeah, technically they're tentacles, but legs is fine. And an octopus has wings. Is that true? No. So is this statement true? Statement is false. Even though that first part was true, we used the word and because we used and, the whole thing has to be true. Both parts have to be true in order for the whole thing to be true. How about the last one? The earth is flat, and the president of this country is Justin Bieber. Is the earth flat? No. So automatically this statement is already false because the earth is not flat. We're using the word and here. Obviously, Justin Bieber is not the president of this country either, so both parts of this statement are false. It didn't matter anyway. We already knew the first part was false, so therefore the statement itself is false. Okay? That's how and is used. Both parts have to be true in order for the entire thing to be true. Okay. So now the word or means either. One part has to be true or the other part has to be true. And if one or the other part is true, then the whole thing is true, no matter how ridiculous the false part actually is. So, if at least one part is true, then the whole thing is true, no matter what. This says elephants have 17 eyes or fish live in the water. Do elephants have 17 eyes? No, obviously not. Do fish live in the water? Yes. And because we use the word or, only one part had to be true in order for the whole statement to be true. You can what? What do you mean? Oh, yeah. Okay, the second one here. Shh. You live in Wyoming, or you live in Rancho Cucamonga. Do you live in Wyoming? Yes. Do you live in Rancho Cucamonga? You have no idea where that is. That's in California. I actually have a cousin who lives there. It's in California, which is close to Africa, pretty much. So is this statement true? Yes, this is true. All right, cats have ears or dogs wag their tails. Do cats have ears? Yes. Do dogs wag their tails? But it didn't matter because the first part was true already, so the second part actually didn't even have to be true at all. But it is true. Both parts are true in this statement, so that's fine. The statement is already true. Grable has a soccer team, or bears in Yellowstone are safe to pet. Does Grable have a soccer team? No. Are bears in Yellowstone safe to pet? No. If you're from other states, probably people think that they are, but no, they're not safe to pet. This is false. All right, in math. Now, that was English. In math, and and or are very similar to the English language. They also have a very important difference. The same idea has to be true for and or. For and, both parts must be true. For or, only one part needs to be true. Okay? So what's going to happen is, graph x is greater than 5 or x is less than or equal to 2 on a number line. We're going to put both of those situations on the same number line. So now I need to have 2 and I need to have 5. For x is greater than 5, my dot will be open, and I'm going to go to the right. That's x is greater than 5. For x is less than or equal to 2, I go to 2, and I'm going to have a closed dot, and I'm going to go to the left. That's an or statement. The word or tells me my graph probably will look something like this. Either these numbers work to make the equation or the sentence true, or these numbers work to make the sentence true. The stuff in the middle does not work. So for example, here's my sentence right here. X is greater than 5 or x is less than or equal to 2. Pick a number. 5? 3. Okay, 3. Is 3 greater than 5? No, so this part would be false. But we have or sitting here. Is 3 less than or equal to 2? No. So this part is also false. Now where is 3 on the number line? It's in here somewhere. This did not get shaded at all. So these numbers here do not work. How about 1? 1 would be in this region right here, right? So we did shade that. Is 1 greater than 5? No. Or is 1 less than or equal to 2? Yes. So because this part was true, even though this part was false, the statement is true. Okay? And that's the idea behind the or. And that's why we wind up graphing something that looks like this. And the same thing would be true if we pick 6. For 6, 6 is greater than 5, true. Or 6 is less than or equal to 2, false. But it doesn't matter, this was already true, so the statement's true. All right, the second one, graph x is greater than or equal to -1. And then we're using the word and this time. And x is less than 4 on a number line. So we draw our number line. We have a -1 and we have a 4. For x is greater than or equal to -1, that will be a solid dot. And we're going to the right. For x is less than 4, that will be a open dot, and we're going to the left. So our arrows kind of point at each other. What we really have here is for this inequality right here, all of these numbers work. So I'm actually going to modify what I have here a little bit. All of these numbers work for that first inequality. For the second inequality, all of these numbers work. But we need both inequalities to be true. So where on this number line are both inequalities true? In the middle. The part where we had the overlap, here and here. All of this stuff in between works for both inequalities at the same time. This stuff over here works for one of them. This stuff over here works for the other one, but only in between does it work for both. Okay? And that's what and needs. And needs to be true in both cases. So 0 would work. 0 is greater than or equal to -1. 0 is less than 4. So 0 works. And anything in between will work. But if I were to pick -3, let's say, -3 is not greater than or equal to -1. So we're already false here, and because of the and, we have a false statement. The same thing will be true over here if I pick +5. +5 is greater than or equal to 1, that's true. But we have and, +5 is less than 4, that's false. So that statement then is false. What you're going to wind up with is a graph that looks like this. Your and statements will all wind up looking like that. Your or statements can look like this, but they can also do this. They can also do this. And they can also do this. But an AND statement has no choice. It has to look like this. Yeah, I know it's terrible. Graph -3 is less than or equal to x is less than 2 on a number line. This is actually an AND statement right here. This is a fancy way of writing an AND statement. You can break this into two separate inequalities. To do that, this is one inequality right here. And this is the other inequality right here. Do you see those two? So I could write -3 is less than or equal to x, and x is less than 2. And now to graph this one is written backwards. So in order to graph it, I have to read it backwards. I'd write x is greater than or equal to -3, and x is less than 2. So now that I have that separated out, I can draw that number line in. We have -3, we have +2. X is greater than or equal to -3, solid dot, up and to the right. X is less than 2, open dot, up and to the left. And notice that it does look like an AND statement that we have right here. So I'm just going to connect those two arrows, and that's my answer. If you look back at the original problem, the way this is written, it says basically x is sandwiched between -3 and +2. And if I pick any number between -3 and +2, it will work. Any number outside of that won't work. So when you see that notation right there, that's an AND statement, and it just means anything between these two numbers works. Okay, now we're going to write some compound inequalities. By the way, we've been working with compound inequalities this whole time. Any inequality that has more than one in the problem is a compound inequality. So which compound inequality represents the phrase, and then graph the solution. It says all real numbers that are greater than -2 and less than 6. There's two ways you could do this. You could do it like we just did on the very last problem. This says we have to be between -2 and +6. So I could write -2 is less than x is less than 6. That would work. That's an AND statement that says that x is between -2 and +6. Or I could write that as two separate inequalities. All numbers that are greater than -2 would be x is greater than 2. And less than 6 would be x is less than 6, with the word and. X is greater than 2 and x is less than 6. Either way you want to write that, we can draw our graph. It's an AND statement. I have a -2 here, I have a 6 here. These are both just open dots. X is greater than 2 goes this way. X is less than 6 goes this way. It's an AND statement, so I'm going to connect the two. Anything in between works. Anything outside does not work. There's no fancy way to write an OR statement. It's just an OR statement. So you're going to write the word OR in between the two inequalities you come up with. It says all numbers that are less than 0. Okay, so that's going to be x is less than 0. Then the word OR, so OR, x values greater than or equal to 5. So I can write x greater than or equal to 5. It's that easy to come up with two inequalities. We draw our number line. We need a 0. We need a 5. X is less than 0. Will be an open circle up and to the left. X is greater than or equal to 5 will be a closed dot, and then greater than is to the right. There's your graph. Again, OR looks like that, and looks like what we have on the left. Go ahead and try the other two. They're very similar to the above ones. How do I write all real numbers that are less than or equal to 2.5? Yeah. There you go. Then or. There you go. Okay, so we need a number line. 6 on the right. 2.5. And you can make that 5 halves if you wanted to. You can make it 2.5 if you wanted to. On 2.5 we have a solid dot, and we're going to the, which way are we going? To the left. And on the 6 we're going to have open and to the right. And an or statement does look like that. So just check real quick, make sure you have the right word for the graph that you're seeing. Okay? If you had an and statement and you wanted the graph that looked like that, there would actually be no solution because there's no overlap. All real numbers that are greater than or equal to -4 and less than 6. So how do I write the first part? There are 2 ways to do it. Let's write it as 2 separate inequalities first. Okay? And the word and x. Okay? And do we have the other way? Can we write it the other way? The smaller number is less than or equal to x. Notice I'm just reading this one backwards. And then less than 6 without having to write the word and. So again, if you want to write it like this, perfectly fine. That's how I usually do it. If you want to come up with this, perfectly fine also. You're going to be given problems that look like this, so you got to know how to work with them. Okay, this is an and statement here. Now I got to come up with a number line, and on the number line, this version right here is actually a lot easier to see, I think. We have the -4 here, we have the 6 here, and x is sandwiched between them. That's going to be a solid dot there, an open dot there. X is sandwiched between them. Solving a compound inequality involving the word and. So you can be given problems that look like this. Now notice the directions we want to solve. We want to write our answers in set builder notation, and we want to graph. So this is just like everything that we've been doing. The difference is now it's a compound inequality. I know it's a compound inequality because of those 2 inequalities in the same problem. So let me get those off of there. Okay, there's 2 ways you can do these problems as well. The most common way is to split this into 2 separate inequalities and then solve. So, this is one inequality right here. This is the other inequality right here. The stuff in the middle is shared by the 2 inequalities. So, for my first one, I'll write -3 is less than or equal to m minus 4. Is this an and statement or an or statement? This is an and, so I'm going to write and then I'm going to repeat the stuff in the middle. M minus 4 is less than -1. Okay, now we just solve the inequalities. Add 4 to both sides here, and we get 1 is less than or equal to m. This is written backwards. Perfect. The word and comes down. Solve the second inequality for m. We're going to add 4 again. And we get m is less than 3. We want to write our answer in set builder notation. Such that, put the m out here, squiggly bracket there, squiggly bracket there. There's your set builder notation. Number line, we have a 1 and a 3. M is greater than or equal to 1, solid dot, up and to the right. M is less than 3, open dot, up and to the left. It's an and statement, so these 2 little arrows should be connected in between, and there's our answer. Go ahead and try that second one. What do we write? And? Okay, and then we just solve like we've been doing in this chapter. So we're going to add 4 to both sides, and we get, okay, now what? And we get, okay. We do have to rearrange that. Y is greater than 2/3. Okay, and? Nice. Good. So we need set builder notation. I'm going to rewrite it. We have y values such that y is greater than 2/3 and y is less than 6. Then we have to graph it. Okay. Both are open. 2/3 will go to the right and 6 will go. And this is an and statement, so that should look like that. We'll connect them, and there's our graph. So that's how you do those. If you want to separate them out, you're certainly able to do that. But if you notice the bottom sentence here, you can also solve these types of inequalities by working on all 3 parts of the inequality at the same time. So let's take a look back at these 2 problems that we did. Notice the first thing we did here after we separated out was add 4. And on the other side, again, we added 4. On this one, the first thing we did was, we have that minus 4 in the middle. We added 4 on this side. We added 4 on this one. And then here we divided both sides by 3. Here we divided both sides by 3. So the point is, you actually don't have to separate these out. You need to understand that it's an and statement, but you can leave them put together. And instead of dividing both sides by 3, you have 3 parts here. You're going to divide everything by 3, all 3 sides by 3. Okay? So what I'm going to do is I'm going to erase everything that's up here, and I'm going to solve these again without splitting them up. And then we'll put it in set builder notation and graph it. So here we go. I have m minus 4. I want just m. So to get rid of the minus 4, I'm going to add 4. But if I add 4 to the middle, I have to add 4 to the outsides as well. Now when I do that, I get 1 is less than or equal to just m is less than 3. I'm already in my answer. I can do set builder notation right there. M values such that 1 is less than or equal to m is less than 3. That's legal to do. Now I can draw my number line. I put my 1 here, I put my 3 here. I'm going to have a solid dot there, an open dot there, and m has to be somewhere between. That's what that says. Okay? A little bit easier to do that. For the second one, what am I going to do first? We're going to add 4. It's the same as what we've been doing. Plus 4. But I added 4 there, which means I need to add 4 to the outsides as well. So that gets me 2 is less than 3y is less than 18. And now I want just y by itself. Divide by 3 here to get y by itself. So that means I'm going to divide the outsides by 3 as well. Yep. Yep. Less than 6. That's already all set for set builder notation. My variable's y. Draw my number line and I'll be done. 2/3. 6. Open dots. Y is sandwiched between the 2/3 and the 6. So there's the graph. You can do it either way, whichever way you prefer. But if you do it this way, make sure you are adding 4 or whatever to all 3 parts, and then dividing by 3 to all 3 parts. All right, to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86. That's actually true. Inclusive means you can be exactly 84, and you can be exactly 86, and anything in between. That's what inclusive means. So let's say you scored 86, 85, and 80 on the first 3 tests of the grading period. So your Chapter 2 test was an 86, your Chapter 3 test was an 85, Your Chapter 4 test was an 80. And now we're at the final exam time. What possible scores can you earn on the fourth and final test? Earn a B in the course. You would love to have these test scores? Yeah. Some of you would probably really like to have these scores. So you want to earn a B in this course. Well, it says that we have to be a test average of between 84 and 86. So that's what this says right here. This right here, if I get rid of this stuff right here, I don't want to look at it just yet. 84 is less than or equal to my test average is less than or equal to 86. Okay? Well, how do you calculate an average? Add all the scores together and divide by the number of scores that you had. Okay? So that's what they're trying to show you right here. We add all the scores together. Here's the 86, here's the 85, here's the 80, and then here's the X. Where did that X come from? It's the last test score. We don't know what that score is yet. So we have to include it so that we can figure out what that score has to be. And then we're going to divide by the number of tests that we're taking in this quarter, which is 4. Okay? So now once that's done, we just combine our like terms and we start solving for X. So I have 84 less than or equal to, what's 86 plus 85 plus 80? 100 and what? 191 plus X, all divided by 4, is less than or equal to 86. Now I want to solve for X. What do I need to do first? What's that? Because right here I'm trying to find the average. This is the average test score here. I want my average test score to be between 84 and 86 so I get that B. Okay? So I'm trying to calculate the average right here. To calculate the average, you add up all the test scores and then divide by the number of test scores that you had. Well, these are my test scores. I don't know this one yet. And now I'm going to divide by 4 the number of test scores. Okay. So we've combined like terms. Now I want to get X by itself somehow. How do I get X by itself? Multiply all 3 parts by 4. Okay? So to show you why, if I had just like 5 plus X over 2 equals 10, what would be the first thing we'd do here to get X by itself? We'd multiply everything by 2. Okay? And then we'd have 5 plus X equals 20. Well, we're doing the same thing here, but we're going to multiply everything by 4. So this guy gets multiplied by 4. This guy gets multiplied by 4. This guy gets multiplied by 4. So we need to know what 4 times 84 is. 336 is less than or equal to 4 times this stuff divided by 4 is just this stuff. So I get 191 plus X less than or equal to 344. And now I just want to solve for X, so what do I do? Get X by itself. Yeah, subtract 191 from all 3 parts. And I draw my line. 336 minus 191. This isn't 191, is it? 86 plus 85 plus 80. Yeah, 251. So this should be 251 here. Sorry, we'll just make that quick change. This should be 251 here. And now we're subtracting 251 from all 3 parts. Okay, so 336 minus 251. 85 less than or equal to X less than or equal to 344 minus 251. 93. So notice that as soon as I started doing that subtraction, I realized that there was a mistake because we wound up getting like 140 something %, which we know we're not going to get. Okay? So that means that our test score has to be between 85 and 93 in order for us to get our B average for the quarter. All right, that's how you would do that problem. This type of problem shows up on ACT tests, just so you know. Exactly this sort of thing, where you're trying to find an overall average, and this is how you do it. So take a look at that last part down there. It says reasoning. Suppose you scored 78, 78, and 79 in the first 3 tests. Is it possible for you to earn a B in the course, assuming that 100 is the maximum score you can get on the test? What do you think? Is it possible that you can get a B? Could be possible? How would we figure this out? So do the same thing as we did before, right? The B average is still 84 to 86, and we need to be between 84 and 86. We're going to add the 4 numbers together. We have 78, 78, 79, and what's the 4th one? No, 100 is the maximum score you can get. The 4th one is going to be X. So we have 78 plus 78 plus 79 plus X over 4, because we're trying to find the average. So now we have 84 less than or equal to what plus X over 4? 235. Okay, and now we're just going to do the exact same thing. Multiply all 3 parts by 4. When you do that, what's 84 times 4 again? We have 336 less than or equal to 235 plus X less than or equal to 4 times 86. 344. And now what? Subtract 235 from all 3 parts. Oops. 235. And we get 101 is less than or equal to X is less than or equal to 109. So what's the answer here? The answer is no. The question is, can you still get a B in the course? The answer is no. Then it says explain. So why is your answer no? Yeah, because in order to get a B, you'd have to score 101 or higher, and we can't go over 100. So the answer is no, can't score more than 100. And the work that we show right here is enough. We've been solving compound inequalities with and. For compound inequalities with or, there is no fancy way to do it. They'll just give you the word or. You'll see the or sitting there. So you know that your graph will probably point in opposite directions when you get done. Just solve the 2 inequalities as you see them and then graph it. So for this one, we will first subtract 2 from both sides. 3t is less than negative 9. Divide both sides by 3 and you get t is less than negative 3. The word or comes down. Subtract 5 from both sides. And we get negative 4t is less than negative 4. Divide both sides by negative 4. And we get t is what? Good. We divided by a negative, so we have to flip the inequality. T is greater than positive 1. We can put that in set builder notation. T such that t is less than negative 3 or t is greater than 1. There's my set builder notation. And then I draw my number line. I got my -3 here, I got my 1 here. They're both open. Less than -3 goes to the left, greater than 1 goes to the right, and that does look like an OR statement. So what should we do for the last one? Okay, on the left side we're going to subtract 7 from both sides, and we get what? Less than -6, okay, and then what? Divide by -2. Remember to flip your inequality when you multiply or divide by a negative number. We get y is greater than 3. The OR comes down. Subtract 3 from both sides. 4y. Okay. Divide by 4. Y is less than or equal to -2. This time we did not flip the inequality because we divided by a positive. It's all set for set builder notation, so we go such that with the y out front, squiggly brackets, and we still got to graph this thing. I got a 3 and a -2. ORs can face each other, yeah, but these are not. For y is less than or equal to -2, that's a solid dot, and then less than is to the left. For y is greater than 3, that's an open dot, and greater than is to the right. So the graph winds up looking like that. But ORs can point to each other. If they point towards each other, then your solution would be all real numbers. For an OR statement, an AND statement cannot look like this. It has to be in like this. If you have an AND statement that does not look like an AND statement, then the answer is no solution.